All right, guys, let's go through a few problems on the 10-8 worksheet. Now, just in case you missed this, on this assignment right here, I only asked you guys to do problems 1 through 21 and just the odds. But as I'm working through a few of them here, I'm going to go ahead and do a couple of the even problems and leave the odd ones for you so you get a little bit more practice. You're welcome, everybody. So anyway, let's take a look at number 2 right here. Our directions for 1 through 3 say find the probability that a point chosen at random from A to K. So starting right here at A and going all the way over here to K is on the given segment. So on number 2, the way we would do this from a notational standpoint is talk about the probability of a point being chosen somewhere between B and I. And the general formula for probability, in this case we're talking about length, would be the desired length divided by the total length. So the region we're trying to hit here in this particular problem starts at B and goes to I. So if B is right here at 2 and I takes us right there to 16, we want to know how likely are we to land on that red segment there. So to find the length of BI, what we're going to do is just take the coordinate of the endpoint, which is 16, minus the coordinate of the starting point, which is 2. Now, you could probably do that in your head, but I'm going to go ahead and write it out here. So a 16 minus 2, that'll give us the length of BI. Down in the denominator, it's the total length. And we know that a point is going to be chosen somewhere here between A and K. So again, if I wanted to find the length of AK, I would take its endpoint coordinate, which is 20, and subtract its starting point coordinate, which is 0. Now, obviously, these ones are pretty quick and easy, and you could have done this in your head, but I just want to show you how to handle this in case it gets a little more complicated in the future. Okay, up on top, the 16 minus 2 is going to get us 14. In the denominator, the 20 minus 0 is 20, and we're going to simplify that by just dividing out at 2, and we're going to get a 7/10 for our answer. Now, that is a perfectly acceptable way to express a probability as a fraction. If you wanted, you could also do it as a decimal and say that that one was 0.7. But what that means then, everybody, is if we look at that diagram again, it means that that red line segment makes up about 70% of the overall purple line segment. And that seems like a pretty realistic answer to me. Okay, so 1 and 3 should work the same way. Again, number 8 is not one that I have assigned to you guys, but I still thought it would be good to talk about, and it might help you with some of the other problems that are located near it. So it says here, the state of Connecticut is approximated by a rectangle that's 100 miles by 50 miles. These East Coast states, especially up in the corner there, are not very big, everybody. So what do we have here? We have about 50 miles running from north to south and about 100 miles going from left to right. Hartford is approximately at the center of Connecticut. That's a big city right there. And they want to know if a meteor hit the Earth within 200 miles of Hartford, find the probability that the meteor landed in Connecticut. Okay, so we need to draw, what would basically happen is if a meteor were to hit somewhere within 200 miles of Hartford, it's going to create kind of a blast radius right there. And we want to know that that thing landed within Connecticut. So what's going on right here is that we're going to draw a circle here with a radius of 200 miles centered at Hartford. So I'm going to switch colors right here, and we're going to say then that, and again, we kind of have to get a sense of the scope and the scale of what's going on in this problem here. Within 200 miles of Hartford, well, the way I've drawn this distance from here to here is 100 miles. So I probably should have drawn this a little bit differently. Maybe I can move things around a little bit and make this work. What happens if I try something here, guys? Can I group all of these things together and then maybe shrink this diagram down a little bit? Okay, let's go with that. And now for 200 miles, that distance needs to be twice this bottom side right here. So I'm going to say that maybe from here to here, that would be 200 miles of Hartford. So, whoa, that's a pretty big circle right there. And this distance from here to here, we're saying, is 200 miles. Okay, so what we have here, not a very good circle here, but that entire red circle represents all of the area that is within 200 miles of Hartford, Connecticut. And we want to know what's the probability that that meteor landed inside the state of Connecticut, which of course is modeled by this rectangle right over here. So in a geometric probability problem such as this, we've got to come up with a couple different areas right here. The first thing I want to worry about is the total area. And obviously the big outer shape right here is a circle. And so to come up with that area here, we're going to do pi times our radius squared. Well, as you can see here, the radius of that circle is 200. So that's going to be pi times 200 miles squared. And that's going to get us, let's see here, 40,000 pi is the area of that entire circle there, and that's going to be in square miles. The next thing we need to know is the area of this inner shape right here that we're trying to hit. So the area of the rectangle, and that's a pretty easy one. That's just base times height, and our base here is 100 times 500. So let me go ahead and fill that in. Base is 100. Height is 50, excuse me, I said 500 a second ago. And that is going to get us a 5 with 1, 2, 3 zeros after that. So that is 5,000 square miles. So we know the total area of the circle here. We know the area of the rectangle. So now we want to know the probability of hitting that rectangle. So the general formula for this is desired area divided by total area. The region we want to know the probability of hitting is the state of Connecticut, which is 5,000 square miles. But the total area that it could hit is much, much bigger here. That is going to be 40,000 and a pi, don't forget that, square miles as well. So we're going to go ahead and put this into the calculator here. Now, one thing to be aware of here, guys, the units are identical on the top and the bottom. Square miles and square miles, those are simply going to cancel each other out. But I think that everything else needs to stay, and let's see what we can do to get this one here. Okay, so I'm going to go directly to a stacked fraction and put 5,000 on the top, and then down in the bottom we had 40,000, and there's a pi down there as well. Oh, which is located, let's see, not here, maybe as a function. Yep, there we go. There's our pi button. Okay, and that got us an answer right here as a decimal of 0.0397 and so on and so forth. I don't think they specified in this problem what format they wanted the answer in. So I'm going to go ahead and just write that decimal down. So that was going to be 0. Let's check this again here, 0.0398. Actually, if we round that, 0.0398. So that's the answer as a decimal, and that would get you full credit right there. What people like to do a lot, though, is also to change that into a percentage. So if you wanted to do that, and I really hope you guys know this trick by now, we would simply take that answer and then multiply it by 100. And this is often the way you'll see probability expressed. So about 3.98% is another way of expressing the same thing, 3.98, and you'd need to put the percent sign after that. So either one of the formats of these two answers would be fine. That one doesn't really work very well as a fraction. So, okay, that's number 8. Some other problems around that might be helpful to you. Okay, let's take a look at these ones. I'm going to do number 10 with you guys. You're going to get to come back and do number 11 then on your own. This is a little bit more straightforward of a probability problem. A point between A and B on each number line is chosen at random. What's the probability that the point is between C and D? So if we want to know the probability of landing somewhere between CD, we need the length of CD up here on the top, but on the bottom, we need the length of the entire line segment, which is AB. Okay, so this one, let's take a look. It looks like C is right between 0 and 2, so C is at 1, D is at 2, and the distance from 1 to 2 is just going to be 1. And on the bottom, A, it appears is at a coordinate of -1, and B is over here at 4. So the distance from -1 to 4 is going to be 5. We would divide this out, but that actually is as simplified as that number is going to get. 1/5 is the answer then to number 10. And number 11 is going to work pretty similarly to that one. Okay, on these problems here, again, you were asked to do the odds, so I'm going to do 14 with you here. And this is a geometric probability, and I wish they gave you one that was a little bit more straightforward, but they're making us jump through some hoops right here. So let's take a look at what's going on. Use the dartboard at the right for the exercises 14 through 16. Assume that the dart you throw will land on the dartboard and is equally likely to land at any point on the board. We want to know the probability of hitting region X. Okay, well, the first thing we're going to need for every one of these problems here is what is the total possible area that we could hit? Well, the overall dartboard here is a square 24 by 24. So we would just multiply 24 times 24, which I believe is going to get us 576 square inches for the area of the entire dartboard. Now, what we want to do is in problem 14, we want to hit region X. So the area of region X, let's see what we can do here. Region X is this circle right here and everything inside of it. So the formula for area of a circle is pi times your radius squared. All we need to know then is the radius of that circle, and it looks like they've given us that information right here, which is 4 inches. So that's going to be 4 squared times pi, and that's going to get us 16 pi square inches for the area of region X. And now for 14, the probability of hitting region X then is going to be the area of region X that we just found, 16 pi square inches, divided by the total area we could be hitting, which is 576 square inches. Now the units cancel here. The answer to a probability problem does not have any units, it's just numerical. And we need 16 pi divided by 576. So let's try that. 16, oh, there is a pi right here, okay? Divided by 576, and that gets us a decimal here of 0.0872. I'm going to go ahead and, again, you can just leave it like that. 0.0872 will work just fine. 0.0872 if you wanted. You don't have to, but if you wanted, you could also multiply that by 100, or really just slide that decimal 2 places over and get 8.72%. That's one that people tend to understand a little bit better. So we're saying that that blue circle makes up about almost 9% of the entire dartboard. Now, when you go to do number 15 on your own, let's talk about that for just a second. I kind of want to help you with this one here. They want to know the probability of hitting region Y. Well, the good news is that the total area of 576 isn't going to change. But if you want to know the probability of hitting region Y, you're going to need to find the area of that red circle right there, but you only want this border right here in between them. You don't want to include what's in the middle there. So to find the area of region Y, you're going to have to take pi times your radius squared. Now this is where I just made things really, really messy here. For the radius of circle Y, you had, let's see where we were at here, guys. You had a 4-inch radius right here for circle X, and it looks like, okay, here we go. For circle Y, it's this one right here. That 6 inches is your radius. So that's going to be pi times 6 squared. But the tricky thing now is you need to subtract the area of circle X in between, which we just found before. So that's going to be the minus 16 pi that we came up with a second ago. So basically you're doing that second circle minus the inner one. Let's see, 6 squared is 36, so this is going to be 36 pi minus the inner circle of 16 pi, and that's going to get you just 20 pi for the 20 pi for the area of circle Y. So you're going to take that number, divide it by this total, and that's going to get you your answer right here for problem number 15. Okay, and let's take a look at these last couple ones right here. Again, I'm going to leave number 17 for you guys to do on your own. I think you need the practice. I'm going to do number 18 with you. This one's actually harder, so you're welcome. So a point in the figure is chosen at random. Find the probability that the point lies in the shaded region. So in number 18, couple of things we always need to know. First of all, what is the total area of the region we could hit? Well, the overall outer shape here is a rectangle. Formula for area of a rectangle is base times height. Well, our base right here is 8, and our height is 6. So this is pretty easy. And the 8 times the 6 is going to get us 48 for the area of the overall rectangle. Eventually, that's going to go in the denominator of my fraction. Now, what we want to find next is the shaded area. And in a problem like 17, that's pretty easy to do. The shaded area is just a rectangle, so you would just do base times height. But in number 18, it's the circle in the middle that's unshaded, and the shaded region is all the stuff that's inside the rectangle but outside of the circle. So what we're going to have to do is a little extra step right here. We're going to have to find the area of the circle. Let's do that first. So that's pi times your radius squared, which, let's see here, is going to be pi times, okay, the radius of that circle, if you were to draw a radius here or here or over here, none of that really helps you very much. What you want to do is draw this radius going right up to the top. We know that the entire right side of this rectangle is 6. That radius is half of that circle, which is 3. So pi times 3 squared is going to get us 9 pi for the area of the circle. But that is not the region that we're trying to hit. We want the stuff that's outside of the circle. So now, to find your shaded area, this might be the first one here we've done together, you're going to take the total area of the rectangle, which is 48, minus the area of the unshaded region that we don't want to hit, which is 9 pi. Now this is going to end up being kind of ugly. Actually, you know what? I'm going to leave it like that. You can't do anything to clean up that answer here, guys, without going to a rounded decimal, which you know I don't like to do. So we're going to say here that your total area is 48 and that the shaded region you're hoping to hit is 48 minus 9 pi. Therefore, the probability now of hitting the shaded region is going to be your desired area, which is right here, divided by your total area, which is right here. So the region we want to hit has an area of 48 minus 9 pi. The total area we could hit is going to end up being 48. Now this is going to be messy here, guys, so we want to go to our calculator to do this, and we want to do it carefully. Let's use the stacked fraction. So 48 and minus 9 pi, that's our numerator, and then 48 by itself is the denominator, and that gets us an answer now of 0.41, that's actually going to be a 10 at the end, 0.4110. for this answer right here, 0.4110. Or again, if you wanted, you don't have to, you could move that decimal 2 to the right and make it 41.10%. Either one of those answers there would be correct. All right, guys, so that's a pretty good jump, I think, on the 10-8 homework. Let's try the rest of those problems. Again, you're just doing 1 through 21 odds right there, so that's only 11 problems. I hope you guys will do okay with that. I'll make sure to get those answers posted. Hopefully this helps, and good luck, everybody.